Good to go.
Get ready to go.
Okay. So, hi everyone. Yep, that's me, Jeromy Anglim. I've been using R for about 5 years, and I've been was excited when Yuval got this group started, and so excited that I wanted to get involved. Gave a talk about a year and a half ago on reproducible workflows. It was a little short talk because we had 2 talks that evening, so both I didn't get to share all the glory that is R and LaTeX and reproducible research. But also in the last year and a half, there's been a lot of advances in reproducible research with R, and also you learn more in a year and a half with R. So today's talk is going to be looking at some of these new technologies, such as knitr or knitr, as it's sometimes pronounced, a document language called R Markdown, and also the IDE that's been getting quite a lot of press in the R blogosphere, RStudio. If you want to see any of the examples that I'm presenting today, because I'm going to run through a few examples in RStudio using R Markdown documents, I've got a GitHub repository down here which has the slides and all the examples that I'm presenting today, so if you want to have a play with them in your own time, you can. And also, I have a blog where I talk a lot about R and statistics and my other interest, psychology. So I just wanted to give an introduction to reproducible research today, talk about Markdown. It's a nice and easy language for writing up reproducible research documents. Then look at knitr and R Markdown, and if we have time, I might show a little example of LaTeX as well. So hopefully have a few examples of using RStudio along the way. I was trying to think of sort of the theoretical overall context of this talk, and I thought to myself, well, we're all trying to produce documents in some shape or form. I'm in academia, so we're always trying to produce journal articles, books, book chapters. In earlier times, theses. Sometimes we might even do consulting reports, but certainly in industry, you're producing consulting reports, presentations, and so on. There are various ways you could divide up the kind of documents we produce. One split I thought was there's sort of informal documents, so preliminary analyses or analyses you're just sharing with yourself or with friends and colleagues. There's even homework if you're doing any statistical subjects. And this could perhaps be contrasted with the more formal documents like journal articles where there's specific styles. You've got to assume a much broader readership. You have to assume that they don't necessarily know what your strange variable name is and what it means. You have to obviously worry a lot more about formatting and these sorts of things. Another split I thought was between kind of content that uses the browser metaphor versus content that uses a page metaphor. So a lot of documents we're creating are designed to be printed, whether they be PDF format or in a Word document, whereas others are designed to just be a continuous stream of text that we don't have to worry about where the page breaks lie or exactly how wide the margins are and so on. So some of those splits, I guess, relate to where what I'm going to talk about today is relevant. When would you use a reproducible research approach, reproducible analysis? When would you use R Markdown? When would you use LaTeX? When would you throw it all in and use Microsoft Word and copy and pasting results from whatever statistical software you're using? So, in broad terms, I guess what I'm going to be talking about primarily today is R Markdown. And I think it's a really good tool for doing preliminary analyses, quick analyses that you want to share with yourself or with others. It's a pretty cool tool for producing blog posts, web pages, and contributing to forums. And potentially, with a little bit of work, you could muscle it into something you could give to a client. But I think at a certain point, R Markdown, you want more power over the formatting and control. You might be slipping into something like LaTeX. When you would use reproducible research, reproducible analysis, whenever you're wanting to combine data and reports into some sort of integrated document in a robust and reliable way. So what is reproducible analysis? I guess I was thinking about this. There's a lot of discussion in the statistical literature about reproducible research and reproducible analysis as what we should all be doing whenever we're analysing data. But I thought to myself, actually, well, the aim of reproducibility in relation to analysis is kind of broad, and it certainly does vary on a continuum. I know a lot of people in psychology, they're taught to run analyses in SPSS, and then they take their graphs and tables and they'll paste it into Excel or something and format the table, and then they'll paste it into Word. And then they'll do some more analyses, and the things will change, and they'll add a transformation or update it, and then I'll have to update this table, and then they'll read, well, a particular value from the table and transpose it into the document. And that's sort of, I guess, a relatively common workflow, at least in the social sciences. And I mean, I've used that myself, and sometimes it works reasonably well. A step up is, you're saving your syntax or your scripts, and you have some at least record that you can go back to and see what you did in some time in the future. So that's more reproducible. But the particular form of reproducibility that I'm thinking of is what we might associate with document formats like Sweave and what I'm going to talk about, knitr. And that's where you have some code. Naturally, it transforms your raw data and processes the data ready for analyses. You run some analyses, perhaps producing some graphs, some tables, some numbers that get incorporated into your report, and then it also gets weaved and integrated into that report. So somehow, magically, the graph will get incorporated into the report automatically, so will the table, so will the text. Ideally, this process is a single click. You have a single document or some single process which you can click, and that runs all the code transformations on your raw data and processes it, runs the analyses, and incorporates it into the report. And therefore, in some sense, that it's an integrated whole, and hopefully you're reducing risks of errors entering. And potentially also, you can verify where errors do enter, because you can check the whole process. It's all written, it's all recorded. If you're in consulting, then you're probably not going to be necessarily posting this all over, these documents all over the world. You might be keeping this to yourself. But certainly, if you're in a scientific context, I think this is sort of the way to go in terms of a gold standard reproducibility. By sharing this whole package in an easily consumable form, you can then allow others to learn from what you've done, learn the exact transformations you've applied, learn the exact procedures you've used. They can extend it, analyze the data in different ways, and so forth. This is particularly pertinent, I think. I'm not sure if anyone's been following some various controversies in social psychology, where there's been these various incidences of academic misconduct, fraudulent data, or there was another instance where someone did an experiment and then started taking out data from the groups, taking the lowest scores out of one group and the highest scores out of another group until statistical significance was achieved. Now, admittedly, these people are not necessarily going to be the ones that are going to be embracing reproducible analysis, but hopefully, as we move forward, I think as we can make, the more we can make reproducible analysis easier, then the more people are likely to adopt it in their workflows, and perhaps even one day there might be a point where it's even mandated. Who knows? You might see the term reproducible research a lot in literature. I prefer reproducible analysis. I sometimes slip into reproducible research, but I prefer reproducible analysis because generally what we're talking about is just the bit where you transform data, run analyses, and incorporate that into a report. Reproducibility, of course, is a ginormous scientific concept about a whole process of scientific research, where I think we're only talking about here about the analyses and the reproducibility of those. So why would we go to the hassle of reproducible analysis? Well, you can reproduce them. So 6 months later, you can rerun the exact same analyses, and hopefully, if no software is upgraded and broken your code, or yeah, hopefully everything will just rerun, and even if it doesn't quite rerun, you can just tweak it a little bit, and you can usually fix it up for any updated versions. So that's nice. You can reproduce it. Others can reproduce it to check that what you found is real. Hopefully you can increase the accuracy of your results. You could exclude errors of just when you update the underlying data because of some transformations. You can make sure that those changes get cascaded through to any graphs and tables. You know, if you decide, oh, I want to delete a couple of observations from my sample because that was dodgy data, perhaps you want to make sure that that cascades throughout your analysis. So there's a way of achieving consistency a little bit more easily. You can also ensure that certain numbers that you read off tables get incorporated exactly, as opposed to the risk of reading off a table and not recording it right. Others can review your analysis choices, and so can you if you choose to share them. It also has the potential to increase clarity of communication. So if you're communicating a results or a methods section in a paper, you can just point to the code and say, that's exactly what I did, as opposed to somewhat more fuzzy approach of using natural language. There's all these little choices. What type of sums of squares did you use? Exactly what algorithm did you use to optimize whatever you were doing? So by having the exact code there, you can certainly increase clarity. And hopefully also increase trust, both by increasing accuracy and also by allowing others to check and verify. So what I'm talking about specifically are approaches where today where we use R and some sort of plain text markup format, such as LaTeX or such as Markdown or any number of other markup languages, to generally produce PDFs, HTML documents, and slides. And probably the dominant one for a long time has been SWeave, and that's still very good. Brew I haven't used so much, but I hear it's quite good. And probably in the last, 6 months, a year, knitr has been getting a lot of press and a lot of discussion in the R world. And so there are many reasons to like knitr, but I think I'll save some of that discussion for a bit later. Just in case you get home and you want to get started on this, this is all the things you might want to install to run through anything I'm talking about today. I'm guessing you've probably got R. I don't know, how many people use RStudio here? Yeah, quite a lot. I mean, it's certainly a lovely entry point into R. There's plenty of other great environments such as Emacs or Vim or any number of other tools, but I really started to like RStudio a lot just because it's quite intuitive and user-friendly, and you don't have to tweak it too much to get it working well. In terms of packages, certainly the knitr package you'd want to have to run the examples. The Markdown package provides a few other options for converting Markdown to HTML. Xtable is good for producing HTML or LaTeX tables. These are just a couple of graphics packages which I use from time to time in the presentation. Pandoc I'll talk about later. That's a way of converting between different markup languages, so going from Markdown to HTML to PDF or to some slide format. It's this command line program for converting between things. And finally, if you do want to get into the LaTeX side of things, because you're doing some journal articles or documents, then you probably want to get a LaTeX distribution. But I probably don't have time to go through LaTeX in a major way today, but the entry point is obviously to have a working LaTeX distribution. I should also mention, if you have any questions you want to ask, or you want to say something I've said is wrong, or you want to challenge something, or you want to just ask a question, feel free to interrupt me during the talk. So I thought, how can you explain RStudio, knitr, Markdown, and R Markdown? I thought, well, the starting point is just to understand what is Markdown, and then I'll move into what is R Markdown. So I've got exposed to Markdown a lot through Stack Overflow. I quite like to answer and ask questions about R on Stack Overflow, And of course, they're proliferating into various other question and answer sites to do with the statistics ones, very good and very popular. And also there's ones on everything under the sun now. So a lot of websites have used this markup language. It's a very lightweight format. If anyone's ever looked under the hood at Wikipedia, you may have seen this markup. Well, Markdown's even simpler. It's generally just provides some basic formatting that is useful for web pages, but it's also quite useful if you just want to have a basic lightweight system of bolding text, making italics, making headings, quoting text. And in particular, it's very good for showing code. It has some nice facilities to incorporate code, whereas if anyone's ever tried to write examples of code in HTML, you'll soon realize, oh, I want to write the less than symbol, and then I have to write ampersand, LT, something, blah, blah. So Markdown makes it very easy to create simple HTML documents. The other nice feature of it is that you can intersperse HTML. So while it's very simple, if you want something more, you want a HTML table, or you want some style sheets, or whatever it might be, you can just write HTML and they'll get added and passed right through. One of the good things, or perhaps bad things, of Markdown is that there's various extensions and flavors of Markdown. So there's the original Markdown. But then some people said, oh, well, I want some extra features, but in Markdown. And so there's GitHub Markdown, which has added a few things. So just to be aware that there are a few different flavors of it, and that can sometimes be important. I'll talk about a few examples later on. So just to look at a few examples. On the left, I've got a screen grab of the source, and on the right, I've got the result. So basically a HTML in a browser. So it's very quick and lightweight to add headings. There are various ways of doing headings, but my favorite is just one hash and a space, then the name, which is heading 1, 2 hashes for heading 2, 3 hashes for heading 3, 4 hashes for heading 4. So, nice and lightweight. If you want to bold or highlight or italicize some text, you can just surround those with double asterisks for bold or single asterisks for italics. If you want to insert new paragraphs, then you just leave an empty line. Much like LaTeX, if you want to use it. Dot points are really easy to do, and I often find this is useful if you're writing up an analysis, you've got a graph and you want to make a few points about it. Just a little asterisk at the start of the line, and then a space, and then so on. Likewise, you can do numbered lists with, I think all you need is just one dot space, and then it doesn't really matter what the other numbers are, it'll just do 1, 2, 3, 4, and so on. So if you want to insert a numbered list, it's just one dot and space. If you want to have indented lists, you can do that. I think I've always indented by 4 spaces. I'm not sure if it's more flexible than that, but you just indent it with some spaces and you can have indented lists. One of the, it's not exactly an extension of Markdown, but rather Markdown can be converted into HTML in such a way that it includes the MathJax JavaScript library, or a rendering engine, which allows you to display mathematical equations in HTML. I don't know, is anyone familiar with MathJax? So it's quite popular on various websites as a way of allowing people to write mathematics on a web page. It supports various ways of writing mathematical equations. I generally just use the LaTeX mathematics. So I guess if you're the kind of person who wants to write a mathematical equation, then you've probably been exposed at some point to LaTeX. And so you can start writing that in. For inline equations, you just put a dollar symbol at the beginning and the end of the equation, and then you put your LaTeX mathematics. So, y subscript I equals backslash is for all sorts of things in LaTeX, alpha plus beta, x sub I plus e sub I. And then that gets rendered in relatively attractive LaTeX. You can also use displayed equations by using double dollar symbols, and that gets set on its own line. So yeah, if you're wanting to write a report describing some analyses, or you're trying to do your statistics homework, then the support for mathematical equations is quite handy. And yeah, so RStudio will automatically insert the MathJax script into the header of your HTML file, so that when you view the HTML file, you can see the equations.
How about if you need other packages for LaTeX, how do you do that? Do you need a specific package for LaTeX?
So you're asking, do you need specific?
Yeah, the package to do the LaTeX. It can easy to do.
For this, you don't. I don't think you need a local LaTeX distribution. I think it just calls some online library of images of mathematics.
No, for this one,
oh yeah.
You don't. But if you for complicated some stuff, you need some specific package for LaTeX. So can you got option you can use?
Basically, R Markdown is not LaTeX. So I guess you're saying if you want to use page formatting features in LaTeX. All right. So then you'd probably use R LaTeX, or basically SWeave, which yeah. So you wouldn't use R Markdown if you want all the features of LaTeX, or if you want to produce a nice, attractive PDF. Well, you probably wouldn't anyway. It'd be much easier just to go the LaTeX route. You can include hyperlinks. There are a few ways of doing this also. The main one is to put it between square brackets the text you want to appear, and then followed by round links, or sorry, round brackets with the URL. Alternatively, you just want to display a URL, you can put it between less than and greater than signs. You can include images with an exclamation mark, and then in square brackets the alt text, I think it is, followed by the location of the file. And that can either be a URL or something local to your computer. Often, if you're trying to show someone else code, or you're a teacher and you want to write a tutorial, then often it's very nice to be able to include code in a natural way. Or likewise, if you're contributing to some question and answer site, you're asking a question, it's very nice to be able to format the code so that it looks a little different. So if you want to have inline code displayed in a sort of typewriter font, then you use separate it by backticks. And all this will be displayed in sort of Courier font. Or if you want to have a block of code, then you just indent it by a tab or 4 spaces. And then all that code will not be processed by Markdown. So if you have dollar symbols or anything like that, then that won't be interpreted as bolding or anything like that. It'll just display as is.
I've got a really dumb question. What's a backtick?
It's the little key in the top left above tab. Yeah.
The squiggle thing.
It's, I guess, shift backtick is the tilde, and the squiggle thing.
So it's got upper quote, back quote.
Yeah. Back quote, is it? Yeah. Sorry, yeah, back quote, backtick.
Okay.
Just left of the one.
Okay. Thank you.
Hi.
Is it possible for that to get syntax highlighting of your code?
In RStudio?
No,
Sorry?
in the produce.
Markdown. Yes. Well, yes.
Stack Overflow does.
Certainly, like when you're doing R Markdown, your R code is automatically highlighted appropriately. I guess this is a little bit different to what I'm about to show around when you have R code chunks, and that code automatically gets formatted. GitHub has an enhanced version of Markdown. I think I'm not sure if you want me to go into it, but I think in GitHub Markdown, instead of indenting all this, you can just put 3 backticks at the start and 3 backticks at the end, and then the letter after the first set of 3 backticks, or the set of the word, tells the language. So I think you write 3 backticks R, and in GitHub at least, it will syntax highlight, but by default Markdown wouldn't. You can include quotes by just appending a greater than symbol at the start of each line. And one of the GitHub flavored enhancements to Markdown. So if you're using RStudio, it defaults to this GitHub enhanced Markdown. You can do tables a bit like this. But if you don't want to be reliant on the GitHub enhanced version, you can just write HTML. And generally, I guess, if you want to have control over their appearance, you probably have to write a style sheet or something like that and add it to the header. I generally haven't found table creation that friendly in R Markdown. And generally, I think if you really want a fancy table, you might want to fall back to LaTeX or something else. But with work, it is possible to produce nice tables.
Does it have any? Because I know some markup languages, if you can just put paste CSV in there if it's just a very regular table and it formats it for you. Are there features like that?
No. You certainly could read in a CSV file and then output it as a table. And there are ways of doing that that aren't too difficult. I guess, yeah, if you just want to produce a table, it's not difficult. But if you want to have precise control over where the lines are and the centering and all that sort of stuff, it can get a bit fiddly. But yeah, you can certainly quickly read in a CSV and then output it as a HTML table. And yes, as I mentioned before, you can just use raw HTML. So you can just write your links regular ways, or you can write HTML symbols or whatever you like. That will just get passed through as Markdown gets converted to HTML. Okay. So anyway, that was just a quick overview of Markdown. And of course, you don't really know any of it to get started with R Markdown, because plain text works fine as well. But once you start wanting to format your document a bit, then there's a very quick set of rules that guide that. And there's also a little help button in RStudio. Okay, so now let's get to the reproducible analysis side of things. So I'm going to be focused on knitr and how we can use that to convert R Markdown documents into other things, and particularly HTML files. And I'm going to be talking about how RStudio is a nice way to write R Markdown and process your documents. It's particularly a nice way of getting started with R Markdown. So yeah, as I say, knitr is a relatively recent package. I'm not quite sure how to pronounce the developer's name, but I think it's something like Yui Xie, maybe. And that's both a package, and he's also sort of set out the rules of the document format, which is R Markdown. knitr is much broader, of course. It allows you to do all sorts of things. It supports multiple languages. It supports multiple, I guess, weaving file formats. So not just Markdown, but you can weave with LaTeX, you can weave with HTML, you can weave all sorts of things. And RStudio is the open source cross platform that makes it easy to work with this sort of stuff. So why might you want to use knitr? What are the benefits? As I said, it supports many markup languages. You can combine your R code and your graphs and tables and text from R into a number of different document formats. So not just Markdown, which I'm going to focus on today. It also supports what SWeave does in terms of integrating with LaTeX. You can write an HTML document raw, but incorporate some graphs and tables that get weaved in. I don't know much about restructured text, but I imagine that's a slightly more sophisticated version of Markdown with a few more options. And I think there's even other formats. A great thing about knitr is it has really nice defaults, so you don't have to worry about sort of weird surprises to do with where do I put my sleeve.sty. It probably doesn't mean much to most people, but there's lots of little errors and problems people often encounter when they're trying to get started with SWeave, just to get up and running. And so it's got nice defaults in that regard. For example, you want to insert a plot, you just write code for a plot. You don't have to remember that you have to specify some option that there is a plot. Or if you want to have more than one plot in a code chunk, you'll do that. So I think it's much easier to get started with reproducible research. And I think R Markdown also makes it even more accessible because the document format itself is so simple. Whereas LaTeX, you have to remember to do a number of things before you even get started with your document. With R Markdown, you can have a blank document with one R code chunk and it'll output nice results. It also, I guess, has a lot of output options, additional output options, which are quite useful. There's even support for other languages. I believe it's possible to incorporate Python or Walk. I'm not sure how much I'd need that right now, but if you want that, it's good. And if anyone has tried to run got some big documents with long analyses, I remember my thesis, it took about half an hour to compile my PhD thesis from scratch. And so I had to try and use all these ad hoc caching systems. Now that there is caching available through extensions to SWeave, but knitr just makes it really easy by default to cache analyses. So if you've got some initial pre-processing that takes 10 minutes to run, an hour to run, in theory you can run it once with the cache option, and then the next time you run, it'll just pull that object directly instead of processing that step. It works quite well. I find, as soon as I've got a slightly long processing time, I'll put on that cache and then things speed up a little bit. Well, they speed up dramatically. And there's a nice presentation there if you want to look at what Iwi has to say about the benefits of knitr. As for RStudio, there are lots of options for analysing data with R, and I guess everyone has their favourite, but I think RStudio stands out as a really nice one to get started with. It's open source, which is great. It works on all 3 operating systems that people are likely to use. I should mention actually all the things today work on Linux, Mac and Windows. Has heaps of sort of useful usability aids. It just works when you get started, and it has very tight integration with knitr. So you get syntax highlighting for R Markdown documents that works really well. You can run code in particular code chunks and so on. And I'll show you some examples of this shortly. But of course there are other good ones as well. So at this point I was hoping to just run through a few examples of R Markdown, starting with something sort of really simple, and then a bit simple, and then slightly more complicated maybe. Just to show what the environment looks like and how it all works. So this is just a proof of concept kind of example to show you what an R Markdown document looks like. So essentially it's in its own folder somewhere on my computer, and perhaps if we just have a quick look at the RStudio environment. I know a lot of you use this, but if you haven't, then it might be a useful run through, and I'll try and highlight R Markdown features as well. But you've got your code files on the top left. You've got a console where you can do things like create variables, produce plots that are displayed over here. You can browse your directory of files. It's a little bit easier to install packages potentially. You can see which ones you've already got installed, and you can load them up by clicking potentially. Help files are pretty accessible in terms of display here. You've got your workspace where it lists variables that are in your workspace, and you've got history of commands you've run. So it's got most of the things you might want readily available. And if you use this, well, if you use RStudio, then you'll know all about that. So it's very easy to get up and running. What about R Markdown and the specific features that it makes available for R Markdown? And to some extent, it's very similar if we were to look at LaTeX or other reproducible document formats. So R Markdown has a .rmd or .RMD extension. So Markdown documents typically have an MD extension, and so it has a .rmd extension. We'll notice that there are a couple of new buttons. One is Markdown Quick Reference. So if you want to be reminded how to do various things in Markdown, there's a quick reference there to check how to do equations or links and so on. You also have a number of options for running code chunks and moving between code chunks. So what is a code chunk, I guess I should probably say. So here we've got, I'll just run this. Here we have some Markdown text, so a heading for some analyses. And then we have this thing here, which is an R code chunk. As with all reproducible research things in R, around this idea, you have some initial opening and closing delimiters, and then you have your R code. So this first line, triple backtick, and then open brace, R. This is just a name setup. It doesn't need to be there, but it's useful. And then close brace. So that's the opening delimiters, triple backtick, open brace R, close brace. Or triple backtick, brace R, a name, and then have some options. And then to end the code chunk, we have triple backtick. These all have to appear at the start of the line. So then we can have some R code. So as per usual, probably when you're running this sort of thing, you'll often put your library statements to import or various packages, or maybe set a random number generator, or potentially import some data. I generally try and put as much as possible. I guess most people do this. They try and put as much as possible of that sort of preliminary stuff in the first code chunk, so that everything else is only really, as much as possible, dependent on that initial code chunk. Okay, so you can sort of see how we can incorporate Markdown with maybe some text, and we can run some basic code to create a random variable and display a data frame. And we can see down here it's displayed in the console, but when I click knit HTML, all this code in this document gets run. And we have the output displayed here in a browser and the input displayed in a separate block. So we can sort of see the output over there. It's just putting the content of the console output there and console input there. We might want to describe our document a little bit more, put in a bit more text, some headings. Instead of show a bit of code, this is just displaying the code. We might want to plot some a graph, which we can see here, and then it also gets incorporated into the R Markdown document when I press HTML. A nice feature that wasn't available in SWeave is that you can include multiple plots. So this first statement produced a box plot, and this produced a scatter plot. It's all in the one code chunk, and knitr does what you might expect. After the first line of code, it produces the first plot, and then it produces the second plot, and it's all output it. Another nice feature is that you don't have to print ggplot or lattice plots. If anyone tried to use SWeave in the past and they tried to do exactly this, they'd see that their plot didn't appear in their final document. Why was that? Because you have to write print. Why? I don't know, but that was the default. So that was sort of an example of one of the things that used to catch just about everyone up. And so everyone who tried to learn SWeave would just lose these 30 minutes here, 30 minutes there, trying to work out why did it not show my ggplot? So that's quite good. Okay, so another nice feature is you can write Markdown with R potentially. So if you want to output literal text that might be incorporated into Markdown, then you can use various options in the code chunk and also combine that with some cat functions in R. Okay, so I should say something about code chunk options at this point. I'll talk a little bit about them more later, but you can see here that there's a few more things going on in this particular R code chunk, in the header of that code chunk. It has the standard triple backtick brace R to start it, and it has a name, which is optional. And then we have our first examples of some options. So if you just type in knitr options, you'll end up on the knitr website, and you'll learn about all the options. But this is one that you might want to use. Results equals as is. They're all in this form. Keyword equals something. So as is tells knitr that you want to output this text literally to the Markdown document. So, for example, instead of outputting text like this, where you've got the two hashes and it's embedded in a sort of code block with code formatting, you can output it literally. So this writes, here are some dot points. \n is just new lines. So you can write that text literally, and it appears literally in your document. Or if you want to generate some dot points by code, you could write something like star, which is the dot point indicator. The value of y equals and then 1 to 3 or something, and